Welcome to the Digital Native Podcast, the show where we talk to engineering leaders about the products they're building and what they're learning. I'm your host, Ryan Anderson. Our guest today has been in software development for more than 20 years. He was one of the founding engineers for Google BigQuery, which turned 10 last month, and he's co-written 2 books on the subject, Google BigQuery Analytics and Google BigQuery, The Definitive Guide. He's now the Director of Product Management for Google BigQuery, introducing Jordan Tigani.
Hi, thanks for having me.
Yeah, Jordan, I'm excited to talk about your team. BigQuery is one of the products that our customers seem to get most excited about, and one of the products that our customers typically first adopt. To start out today, can you tell us more about your background, how you got into technology?
Yeah, sure. I mean, I think I've always known I wanted to kind of do something with computers ever since I think I got a programming book from the library in 3rd grade, and the idea that you could make it do something for you was pretty exciting. I guess for a 3rd grader, you know, nobody does what you tell it to do, and the computer will do exactly what you tell it to do. And you know, that sort of got me hooked. And then I think, you know, I became a software engineer. Was, you know, very excited about building stuff, and I really like designing things. And I think I found, like, kind of as going from an engineer to a manager, you know, managers design too. They just design with people, and you know, kind of the larger the thing that you're designing, the more ambiguity you get. You know, like the harder the problems are that haven't been fully defined, or you don't fully understand. And so then as a manager, you kind of you're designing with people, and people are the most ambiguous because people don't do what you tell them to do. And especially at Google, as a manager, if you tell somebody to do something, you know, you've just sort of violated your trust with that person. And so you have to figure out how to get the right result with, you know, these things that you don't understand. And people are great because people will, you know, computers always do what you tell them to do, no more and no less, but people will often do, you know, amazing things you didn't expect. And the key is to kind of to let them, you know, give them the right tools that'll let that happen. And I think, you know, my switch to product management, you know, product management is also a design problem. It's designing in product space. It's designing in customer space, and how do we solve these things? You know, the customers want this, but it's going to take us this long to build it, and you know, we have this current technology. Like, how do you kind of triangulate that space? And so this has been sort of an even more exciting challenge than just sort of being a manager or an engineer. I still love that other stuff, and I still, you know, sometimes miss writing code. But it's also exciting to kind of get to see the bigger picture.
Yeah, it sounds like you've you know, really evolved in a lot of different roles while at Google. Take me back, you know, how did you first start working for Google and end up at the company?
You know, I think I'd worked at Microsoft for a while, and I almost worked at a team. I was in a team that got reorged. It was a research team that got reorged into the team that built Azure. And I'm like, oh, well, this seems like really far-fetched. And so I just missed out on being part of the team that created Microsoft's cloud. I went and I worked at a couple of startups, and then I came to work for Google. And, you know, I happened to be at the right place at the right time, and to help, you know, the birth of Google's cloud, which, you know, we didn't know that's what we were doing at the time. We were just sort of taking some internal tools and kind of making them available to the public. But you know, I liked working at startups. I liked the fact that, you know, you had a lot of autonomy and a lot of impact at a startup. And there was an energy at Google that was you know, it just felt like an engineer with an idea could change the world. And so, even though it was a big company, it was a much less big company than it is now. But even though it was a big company, it sort of felt like some of the things that I liked about startups. And then it was also, you know, I mean, there's just a lot of great things. You know, I felt like for a while it was like daycare for engineers. You know, there was snack time and nap pods and toys and all this stuff, everything that you could want. So yeah, it's a good place.
Yeah, and the culture for me early on was definitely, you know, a pretty drawing and pretty pretty appealing. So for context, that was about 10 years ago that you joined and started on BigQuery.
Yep.
So for context, I was sharing with you prior to this call, I was finishing up my information systems degree in college, and I took a business intelligence course. This book was written in 2008. So not long after, you started this product called BigQuery, you were one of the founding engineers. Take me back to that time. I mean, to me, BigQuery is a product that really exemplifies the nature of Google Cloud. Massive scale, it's serverless, the interactivity of the product. Take me back to, I guess, the concept stage. What was that time like? I mean, how did you guys kind of come up with the idea?
There was a half a dozen of us or so that got put on this new project, and that was a huge team. But at the time, this was like a major bet. If by comparison, it was only a few years after Gmail. I think Gmail was started by 5 engineers, so like this was sort of a bigger investment than Gmail was. And we were asked to go build a data marketplace. And so we sat around and like try to figure out, okay, well, the data marketplace, what do you need to, you don't like, we're Google and big data is the new buzzword, and like we want to have large data, and you don't want to just have a download link that lets you download these giant data sets. You want to be able to do something with them. And so like you need to be able to, like, what does you want to do over them? You want to compute with them. And SQL is a great way to compute. We have this awesome internal tool called Dremel that can compute like over massive data sets very quickly. So let's externalize Dremel and kind of we'll build that as like step one of our data marketplace. And I think it just goes to show kind of the ethos of Google at the time, where we never doubted that we could do this. Like that nobody was going to say like, no, like you're not building the right data marketplace. Like it was like, hey, we're engineers with ideas. Like we're going to build this and it's going to work. And it did work. And I think we've been on the cusp of a data marketplace. It's always been like 2 quarters out for the last 10 years. But we were really kind of like, one of the things we were thinking is like, with large data sets, you want to move the compute to the data rather than the data to the compute. So we want to take the compute cluster and run that where the data is, and that data is going to live in Google's cloud. Google's cloud wasn't a thing yet, but so we were still in the process of trying to make that a thing. And I think that's also been a theme that has gone through with us, is just sort of like, don't move your data. Like you have your data, get your data in place, get it in BigQuery, and all the other stuff you can do on top of it, you want to be able to do without moving your data, whether it's data science, data, machine learning, exploration, like business intelligence, like see if you can avoid making copies of your data.
And I think that plays into some of the competitive advantage we'll go a little bit deeper into later.
Sure.
So for context as well, I mean, when you guys started this project, the cloud was still in its infancy. What did the landscape kind of look like at that time when it came to data and analytics? What were some of the key product decisions that were made that's helped, make this product so successful?
I mean, Hadoop was still like, MapReduce was still the buzzword, and people kept saying like, well, how is this different than MapReduce? It almost sounds kind of silly nowadays, especially since, thinking like a data warehousing versus MapReduce. But I think, there was, some technologies that came from Google papers and that were kind of externalized by or popularized by other folks, like MapReduce and HBase and, those types of things that were, they required you to think differently about how you were doing your analysis. And I think a lot of people were sort of like, well, okay, we're going to abandon, strong consistency in favor of eventual consistency, and that's going to help us scale out. And then, I'm going to decompose what I'm doing and just sort of map phases and reduce phases. And that lets you kind of do a lot more. And I think one of the key things is like that, by that point, Google had already sort of moved on and said, no, actually, you do want strong consistency. We were building Spanner. We had Megastore, which was sort of a precursor that gave you kind of ACID consistency. We had, we had Flume, which, we later externalized as Dataflow, which kind of lets you use the same mechanisms or the same like concepts to think about kind of your data, but be able to do it in a massively scalable way. And then we had Dremel, which became BigQuery, which basically said I can just run a SQL query, any SQL statement, and that's just going to work over my data, and I don't have to, like, if I'm used to SQL, I don't have to think about it differently. I can just use that same SQL. And so I think that was one of the key kind of like steps that we had sort of made is sort of as Google was, everybody else was thinking about, hey, this is great, we can scale, and we were thinking about the next step, which is like, how do we make these scalable solutions kind of work in people's kind of existing mental frameworks as well as kind of like technological frameworks.
No, that makes sense. And the theme I hear a lot is Google is typically a few years ahead, because a lot of the technology that we develop, we came up with to solve our own internal problems.
Yeah, I think we started that. I mean, I think we were some of the first ones to really kind of get the sort of the scale out as opposed to scale up, and I think that was a massive revolution that we had a big head start on. I think the rest of the world is caught up. I think we have it's a much, I think, more exciting market of ideas nowadays. We also have to look out elsewhere to see what's going on. We can't just sort of assume that we're ahead.
Yeah, so that's a good transition. You speak to a lot of customers, you do a lot of research. What are some of the trends and common themes that you're seeing when it comes to data and analytics out in the industry?
I think when we started BigQuery, the big buzzword was big data, and now everybody sort of rolls their eyes. And like the thing that we keep hearing, it's also the sort of buzzword that's both meaningless and meaningful at the same time, is the digital transformation. It's meaningless because what does that mean, a digital transformation? But it's also meaningful because like people are making a transition from going like from kind of having data locked up and maybe having a couple of reports to really kind of democratizing the analysis and understanding of data and kind of exposure to data, and really kind of making data-driven decisions. So I think like the whole reason that you want to do analysis over your data is so you can make some sort of decision based on that data. And people are generally bad at that. And I think as data sets get larger, it's harder to understand. Like, you can't just, if you have a spreadsheet, you can kind of look at it and like be like, okay, I can see some patterns here, and maybe you have some charts. If you've got a trillion rows of data or 100 trillion rows of data, you can't look at that and make any kind of get any actual understanding. And so kind of people are a little bit lost as the data sizes increase. They're sort of lost on how they can get the same sort of knowledge about what's going on. If you've got 100 million users or 1 billion users, how do you get it? Like you can't ask them all questions. You can't have relationships with all of them, and so you have to figure out other tools to understand what they're doing. And I think that trend has really kind of worked well for Google and for BigQuery, because that's something that we do really well, and we can give people a sort of a lifeline that says, hey, like, I don't care how big your data is, like, we can handle it, and we can let you. Google has a lot of experience making data-driven decisions and understanding. I think Google has 9 products with over 1 billion users. Like, we've had to understand how to do this, and we can help.
That's great. And any common challenges on the other side of the coin that you're seeing?
Common challenges. I think migration, is hard. People have a certain mindset or a way that they've been doing things, and or they just, they're comfortable with a particular set of technologies, and how do you get them to use different technologies? Because even if we're trying to make sure that you have the same general ideas, like hey, it's just SQL, if it's different SQL than you're used to writing, then it's going to be hard. Or if you don't have indexes, or if you don't have some of the same, sometimes we don't, we try to build something that has very few knobs, but sometimes people get used to the knobs that they've been constantly tweaking. So that's been that's one of the big challenges.
No, that makes sense, and change is hard just in general with anything. But for me, what gets me excited about our job is sales. I tell people is innovation and marketing. It's fun when you find something that's innovative and can really make a change. So I guess just out of genuine curiosity, are there certain types of customers or industries that you're seeing be the most innovative in this space right now?
I think financial services are really picking this stuff up and pushing on it, because they see the ability to mine data is their competitive advantage, and like the better you can do this, like the further you can push your data, and the more kind of juice you can squeeze out of it, the more you can the more you can get that trade in before your competitor, the more you can kind of recognize something before the market does. I think the retail space has also been a really interesting one. Just that I think the retail space is the folks are really kind of aggressively embracing data, because they realize that they can get business value out of understanding their customers, understanding regional variations, understanding how their marketing campaigns are paying off, understanding how does product placement in their stores impact impact sales, and especially as a lot of these retail companies have gotten very large, that they have to apply some of the same sort of kind of mining techniques or techniques to kind of understand data as perhaps Google does to understand Android customers, et cetera.
Oh, that's great. So one of the questions I had for you that I was interested in is, you're involved in the process when folks and companies are selecting a data warehouse. In your opinion, nowadays and given current technology, what are some of the things that companies should be taking into consideration when they're selecting a data warehouse?
A great question. I think the one of the things is not what your current data warehouse does or your current data system does, is what do you want to be able, what do you want that to do when it grows up? And I think sometimes people, they get fixated on trying to say, I want to just shift everything over exactly as it is, and I want it to work exactly the same, only I want it to cost less, and I want it to be more scalable, and I want it to be more reliable, and all these things that yeah, maybe we can do that for you, but really what are the other things that you can do that you might be missing out, or what are the ways that you're the things that are hidden in your data that you might not be taking advantage of, like being able to do predictive analysis, being able to do real-time analysis. Like people, traditional data warehousing people, build reports maybe from last week or maybe from last night, and they email the report to the CEO, and everybody pores over it, but those are really quite static, and there's a lot of value in understanding what's going on now, and what has happened. The world is changing quickly, and the faster you can adapt, the more competitive advantage you can have. And then also being able to sort of say, I don't just want a static report. I want to be able to drill down and dig into, ask the follow-up questions. Is this a real trend, or is this an artifact because you had there's one giant customer that did something different, and those kinds of things can be hard to tease apart if you're just sort of looking at static reports. So I think looking at what are the things that you want to be able to do, and as opposed to just looking at the things that you're already doing.
It's interesting. In business, companies do these horrible things. They're called RFPs, requests for proposals, and they try to take something really complex and what they're trying to do and fit it into this two-dimensional check mark box. What we encourage people to do is, rather than say, hey, can you process streaming data? Check mark. Can you process streaming data? To really look at the quality of the product. How much data can you process? How fast can you process it? Can you do it at scale? And I think some of the, these things are where BigQuery really shines. Can you share, where do you typically see customers first engage with BigQuery? And are there any common, compelling pain points there?
So I think one of the things that we try to suggest is, I mean, sure, there's the folks that are like, hey, my existing data warehouse is either end of life, or it's going up for a license renewal, and so I want to move to the cloud, and they want to do a big lift and shift, and that's common, that's possible. We were working with lots of these folks, and we have partners that will help with that, and workload migration, translation, tooling, all sorts of that stuff. But I think one of the best ways is people to recognize something in their workload, something that is not working well, something where perhaps it's they need more granular data, but they've been throwing data away because it doesn't fit in their data warehouse, and that their data lake is too swampy, or is too difficult to use or too slow. Figuring out like, are these where your current pain is in your data management, your data analysis, and trying it with BigQuery. And very often, like, you can take one of these things and you just upload the data into BigQuery, try a couple of your queries, do some exploratory analysis, and people find like, hey, wow, this is amazing, this is simple, I didn't have to spin up any instances, I just started typing queries, and then we find that it kind of spreads virally throughout an organization, because somebody will find it works, and then somebody will be like, oh, okay, well, if I could join that with the marketing data, then it would be great. And then the marketing team uploads their data, and there was one company that I talked to, and like, I was in town, I ended up talking to them, and just sort of on a spur of the moment thing, and I think there was like a dozen or 24 people showed up, and like they're talking about, oh, BigQuery is great, we're using it for this, we're using it for this. They had like 25 teams that were using it, and then there was a guy sitting in the corner, he was the CTO, and he's like, yeah, well, we've standardized on a different cloud, and so like our goal is to not use this, but like it had just, like, because somebody had found some workload that it worked really well at, like it just kept spreading, even though kind of their institutional policy was like, no, we shouldn't be doing this. But it's like, I think it does give people a big advantage, and it does kind of showcase something that you can't necessarily, people aren't getting elsewhere.
And again, no, that's great. Not getting it elsewhere. I mean, I've shared with you, customers here in the Northwest, I've seen BigQuery be the first Google Cloud product they adopt. I think for a number of reasons, but I mean, it's again, you hear that is, we're all in on this cloud, and customers are starting to realize, hey, I don't have to be. I mean, I can choose I can have a best in breed strategy where I don't have to go, make all my servers HP. I don't have to make all my servers Dell. I can kind of pick and choose based on what works best, and what's going to give my company a competitive advantage.
Yeah, and
go ahead.
Yeah, and it works really well. And I think people get worried that, like, oh, well, is this, do you have examples of people that are doing this? But it's super common to have the serving stack on one cloud, analytics on another cloud, data cold storage on a different cloud. I was talking to Gartner last week, and they said, they did a survey, and they said 80% of enterprises were using multiple clouds, and then one of them said, yeah, actually, the other 20% are using multiple clouds. They just don't know it. Like they just don't know enough about what's going on in their organization, because there's acquisitions, there's all sorts of stuff that happens, and so yeah, I mean, BigQuery works great as the only thing in Google Cloud, and I think it often ends up pulling other workloads over, because you're like, okay, well, if my data's here, then I'm gonna do some other data processing, or I'm going to store, we're going to move my data lake here, and then it can pull things over, but customers are in control, and they can choose, as you mentioned, sort of the best in breed.
Yeah, and best in breed. I mean, I guess maybe taking a step back, what are the strengths of GCP in general and BigQuery when it comes to data and analytics? And how is BigQuery unique? What's the competitive advantage?
So I think the overall data analytics competitive advantages are really, we have an ecosystem and a platform for data analytics that works really well together. So we have data flow, which is our kind of streaming system, and kind of high volume data processing. Then we have data proc, which is managed Hadoop and Spark, and then we have data catalog and Cloud Composer, and all these things, Cloud Data Fusion, and all these things work really nicely and just sort of give you this broad platform of, hey, if you hit a wall with one thing, and it's sort of like, okay, well, I can connect it to this other thing, and like it's just sort of like these Lego blocks that connect really nicely together. Other competitive advantages, are things like we have really rich geospatial, like more and more data these days has a lat long involved, or is related to the real world. It's got an address, and you can do IP, lookups, etc. And being able to sort of relate that to the real world, and say like, hey, within these, customers within 10 miles of a store, give them a discount or something, like, or use that to figure out where you're going to put your next store. There's lots of really interesting questions that you can do with geospatial. Machine learning, integrated machine learning. BigQuery can do machine learning without moving data out of the database, and just I mentioned before, like, we don't want you to have to move your data. You can build machine learning models just by writing a SQL query. You can run large scale batch predictions by writing a SQL query, and then you can integrate that with your ML serving as well.
And I've read some case studies from BigQuery, and it's unlike a lot that I've seen in the industry. We have case studies, 52% lower TCO when a customer migrates from on-prem, 41% lower TCO when moving from AWS. People talk about the separation of storage and compute. What does that enable companies to achieve when it comes to efficiency?
Yeah, no, I think that's a really important part of it. I think, like if you're kind of, in the old days, you had a box, and it sit in a data center somewhere, and that was your data warehouse. And when it filled up, either with storage or because you were running too many queries, you needed to buy a bigger box. And I think those boxes were not necessarily one size fits all. It was sort of like, well, some people do a massive amount of queries, but not a lot of storage, and some people it's vice versa. So separating those two out is important. The other thing is just sort of letting them scale infinitely. So like, in BigQuery, adding additional compute capacity is essentially just sort of like is making an API call that says, I'm going to have more slots, and that takes effect immediately. and even existing queries can start to scale out. And then from a storage perspective, we have customers that are storing hundreds of petabytes. Google has clusters Dremel clusters that are multiple exabytes, and so one of the things is just if you have inexpensive storage that scales out, and one of the things people find is that they have a lot more data than they thought they did, because in order to fit their data in their data warehouse, in order to fit the data warehouse data in something that could be considered hot data, because even things that tend to scale out well, the hot data is going to work better than the cold data. BigQuery gives you just random access to all of your data, and but so people tend to narrow their data down, and they were throwing away massive amounts of data. I mean, to give an example of one large retail customer moved to BigQuery from an on-prem data warehouse, and they had 100 terabytes, and they're like, this is huge, 100 terabytes. And okay, 100 terabytes. They moved to BigQuery, and in the last 3 or 4 years, I think they're up to 30 petabytes of data. And it wasn't that their data ingestion rate has increased. It was just that they were throwing away a lot of data, and now they realize, hey, this is valuable. It's valuable to keep this full granularity, full history of data. And they've been able to. So yes, they were able to get lower TCO and lower or better total cost of ownership but then they also found that there were new things that they could now do. And so they were getting more value as well as less cost.
That's incredible. I mean, it's like a 20x plus increase in scale in the amount they were able to hold. So you talked about there being value in capturing and storing this data. I think what's interesting is people are starting to realize that the value of data, it drops considerably. It's still valuable when you have it and you can do analysis. But from the time it's collected to the time it becomes historical data, I've heard data, that's only a minute old is 10 to 15 times more valuable if you can make a decision on it on the time it's collected. Can you speak to how we're helping companies, make decisions and get insights from the data that's happening now?
Sure. Great question. I think a lot of what BigQuery does, and I think some of its differentiators are on the real-time side of things, and being able to, and then kind of as you were alluding to, there's two sides of it. One is collecting data quickly. So you need to get the data in while it's fresh. And then the second is you need to be able to react to it quickly. So you need to be able to make a decision while it's still fast. So you need to be able to have high-speed ingestion mechanisms to get fresh data in, and then high-speed query mechanisms to be able to do the decisioning. And so we have BigQuery has a streaming system where you can write data directly to BigQuery. It's just a really simple HTTP post request. You can fire off a request, writes a line of data. As soon as that request returns, queries will be able to incorporate that data. So the data is incorporated immediately, and then you want to also have low latency. So we're doing a couple things in BigQuery for low latency queries. One is small queries and low latency queries has been a huge one of our huge emphasis in the last year or so. And one of the ways that's surfaced is something we call BI engine, which is one way to think about it is BI tools like Tableau and Power BI. They will, in order to be able to make them interactive, they will pull data out and cache the data somewhere, and then that's their very fast copy, and then they run. They generate their charts based on that. But the problem about that is as soon as you pull that out, then it becomes old. And so if you're trying to do real time things, then you're doing it based on kind of an old snapshot of data. The other problem about that is that from an access control perspective, like every time you make a copy of your data, you have to worry about like, okay, now who gets to access it? And so, so BigQuery has this BI engine, which sort of sits. It's a layer that sits inside our storage engine, but sits on top of the regular storage that's stored in memory, and we can give very, very fast access. And it's kind of the equivalent of like the Tableau extract or the Power BI extract, but it's fresh and always up to date. And so we can basically keep that up to date. And so you can do, you can have a dashboard that runs off of BigQuery. It's fast, and B, it's going to show you the data that is as fresh as possible. And so you can really make decisions in seconds about about things that have happened just in the last few seconds.
And I think there's really an opportunity for businesses right now to kind of pair those capabilities of the real-time data and the machine learning capabilities, and create a really strong competitive advantage as they're creating their product and taking it to market.
Yeah, I think a great example is Geotab, which is a customer that they are doing some really interesting things. They stream data from a bunch of different devices, like essentially IoT devices in vehicles, and those get streamed into BigQuery. They get joined against like BigQuery weather data. Sorry, because we have public data sets that have from NOAA that have weather data from weather stations around the world, and then they use BigQuery machine learning to build machine learning models, and BigQuery geospatial to kind of relate it to maps to basically map out where there's going to be adverse weather conditions based on weather patterns and other kind of driving conditions, and they can do that in real time, and they can serve that up in real time. So it's a really interesting kind of way to just sort of take all of the so many of the kind of the key pieces of BigQuery and kind of tie them up together in one use case.
So where I think this gets exciting, you're speaking about customer stories. At the end of the day, it's not about the product being faster or cheaper or quote unquote better. To me, where it gets exciting is what are we helping our customers achieve? How are we breaking down barriers to things that used to be impossible and helping them differentiate? Can you speak to maybe some customer stories or success stories, or what we're helping our customers achieve in market?
Yeah, I think one example would be a large I guess consumer goods manufacturer. After sort of the COVID-19 crisis happened, it was a significant challenge to their business, and as it is to many businesses and people, and they were able to use the public data sets that BigQuery has, like that kind of track COVID-19 spread, that come from Johns Hopkins and the New York Times and the Google mobility data set, and they were able to use those to kind of help plot out where their customers were going to be impacted, and where their stores and their supply chains were going to be impacted, and it really allowed them to help them weather what was going on and be able to understand what was going on, and being able to sort of work on those kinds of things. It feels pretty meaningful, like when all this crazy stuff is going on and you're like, you feel powerless, and then it's sort of like, well, I can do a little bit. I can make some data available. I can help people make decisions or understand the crisis, and maybe they'll be able to help. And so we've done a bunch of stuff like that, kind of both as part of our public data sets, and then behind the scenes, and kind of working with some researchers, et cetera, on how do we make them so that they can focus on solving problems rather than like on technology and paying for things, which is a nice thing about being at Google. It's other examples of customer things, like you just a large retailer was able to, like, that was very traditional, very much like, okay, we're a traditional data warehouse company, and like just they've started to do so much real time, and started out real time and streaming and web logs and really getting value from real time. And then they also started, now they're one of our big machine learning users, and they've also sort of picked up machine learning and using it to sort of predict or to build content promotions and et cetera. So yeah, lots of, and that's the thing that I love about the job, is talking to customers, understanding how they're using the product, and understanding, like, yeah, we're solving real problems.
And I've been really impressed by, across our product team, the way that you guys engage with customers and really understand, what they're facing, what are their challenges, and, build our roadmap to accommodate. So I think that's a good transition, for you in building out the roadmap. You've alluded to some of the products and some of the things you guys are working on, but is there anything that you're particularly excited about when it comes to the BigQuery roadmap?
I think, yeah, at Google, we tend to not talk too much about roadmap, but I can talk a little bit in sort of like hand wavy things. I mean, one is better low latency queries and sort of instantaneous results. The other one is, Google closed the acquisition of Looker a few months ago, and I think one of the main reasons that drove the Looker acquisition was how it interacted with our analytics portfolio, and in particular BigQuery. Looker works really well with BigQuery already, and one of the key things about Looker is instead of pulling data out of the data warehouse, it sort of operates directly over those data sources. And so for something like BigQuery, you push the queries down to BigQuery, you can really do exploratory analysis. And then when you add on the BI engine layer, if we can get sort of instantaneous, 10 millisecond, 50 millisecond responses, then you don't need all this extra junk, all this extra, this cache somewhere, and we can have that be a really great seamless experience. And then so I mean, that's that's the sort of the simplest level of integration. And then there's a lot more kind of deeper integrations that we've talked about. I mean, like, one of the great things about Looker is this object model where you kind of define a calculation, or you define a concept once, and your entire organization can use that, whether it's lifetime value or kind of revenue, and like this, often data is messy, and it's sort of a way of just sort of like you can kind of define how your object model, how your data relates to other data, and then you can compose those things. And so anybody can sort of start composing these things and actually get really high quality and correct. The key thing is correct business intelligence from that. And we're talking about sort of moving this stuff closer and closer to BigQuery, and sort of tighter integrations with BigQuery. And don't want to talk too much about stuff in the future, other than just to say that, like, I think the Looker and BigQuery integration is going to be awesome, and is going to be, they already work well together, and they're going to work a lot better together. I also want to say that BigQuery works with other works with other BI tools. We're going to continue to work closely with those BI vendors to make those work better. Looker works with other data warehouses. They're going to continue to work with them and make sure that they continue to work well. That's really important, and I think it's really important to make sure that people want to use the BI tool that they want to use. And so we're not going to go in and tell you, okay, you have to use Looker, just like Looker is not going to say you have to use BigQuery. But if you do, and if you're open to kind of using them both, then you're really going to get kind of a best of both worlds.
Yeah, and that's great. That's great to hear. I was in the BI space for the first 5 years of my career, competed against and often lost against Looker. And so I'm excited about some of the stuff that's coming out on our roadmap, with a product that people really love as soon as they start trying it. They see how special it is, similar to BigQuery. So a handful more of questions. Want to take the interview a bit more personal.
Sure.
You've been with Google now a decade. Looking back at your time, are there any favorite projects or things that you're most proud of in your time at Google?
So I was the tech lead for the BigQuery storage for several years, and I think at the time, when we started building BigQuery storage, a lot of people didn't even think that it needed its own storage system. If you think of a data warehouse, like of course, a data warehouse manages its own storage, but internally Dremel did not have its own storage, just sort of operated over files, and sort of like that's why Presto and Athena and some of these other tools, they require you to manage your own files. On the other hand, they're not really data warehouses, and so I think we built some really cool stuff into the storage system that's enabled us to scale out to exabytes and scale and build ACID transactions on top of the system that we had. That I think it was what enabled us to become a true data warehouse, unlike some of the other kind of antecedents. And so that was super exciting, and that was just sort of a fun project and a fun ride to build. Also, the new streaming system in BigQuery that kind of rewrote our storage system to be fundamentally stream based. And I got to work with some of the kind of the legends at Google, like Sanjay Ghemawat, and who kind of took an interest in the project, and working with our one of our other TLs on that to make that work and make that happen. And Andrew Fikes, like one of the key folks from Spanner and Bigtable. Like anyway, so that was sort of fun because it was a pretty green. It was kind of retrofitting, but also kind of building a new scalable system, and doing it the right way. Because when we did the first time, like it was kind of seat of the pants. It was sort of like, all right, well, we need this, and like, okay, it was like building the train tracks just ahead of the train that's running, and this kind of let us say, like, okay, well, what's the right way to do it? And it's taken a while, but it's really starting to pay off now.
That's great. Again, 10 years, the industry's changed rapidly, and it's so different from when the project was started. Has there been anything, as you look back, where you've really changed your opinion when it comes to this space, data and analytics?
Yeah, there's been a bunch of things. Like I think one is, I can say that there was a significant amount of hubris when we started about like, well, if it works for Google, it should work for everybody. And because Google had seen a lot of really massive scale, and sort of it's like, and we're like, well, it works this way in Google, and you don't need X, Y, and Z at Google, and so you won't need it elsewhere. And so, that was sort of beaten out of me really quickly. Recognizing, and Stack Overflow, we used to, we still do, but like, the Stack Overflow community was a great way to sort of get feedback, where people, post things on Stack Overflow, and they're like, oh wow, like this really isn't working for people, and kind of you can use that to be like, yeah, like, these, internal users, for example, of Dremel don't do joins, and so like internally, like people thought, oh, okay, maybe joins aren't that important, and like obviously for any data warehouse user, you want to have a dimensional model and Kimball method and all these things, and like it's like, yeah, of course you need joins. Even things like our original SQL dialect was not standard SQL and had some kind of quirks, and it was like, oh yeah, well, because this is letting you do something that you couldn't do before and at a scale you couldn't do before, then it doesn't have to be standard SQL. And I was really wrong about that one, and I'm really glad that we fixed that in I think 2015 was when we kind of moved to standard SQL. But yeah, it's been a humbling learning experience, and that's why I like working with customers, because they tell you when you're wrong, and they tell you, and then they tell you long enough and often enough, and you believe it, and then you can actually fix things, and they can beat the hubris out of you pretty quickly.
I love that. I mean, there's no substitute for direct customer feedback and incorporating that into the product. Where have you failed in your career, and what did you learn from the experience?
So I think it's interesting. I think there's just in general, if you think about failure as, I mean, almost just it presupposes that you're thinking about things in terms of the destination and not the journey. And so it's pretty rare that there's something that just spectacularly explodes and you're like, oh wow, I screwed that up. But often it's something you're like, yeah, I really wish this had turned out differently, or I wish I would have done better on that interview, or I wish that I would have gotten that that role or that thing. And that happens all the time, and there are setbacks, and there are things that you want that you don't get. And if but I think you kind of have to be you learn from those, and those are kind of setbacks, and those are necessarily they help you get to the place that is the important place to get to. Just to give maybe at risk of sort of a digression, just to give an example, in I don't know, 2015 or something, I ran Chicago Marathon, and I finished in I think 3 hours and 51 seconds. So I was just a few seconds away from a 3-hour marathon. And so one way of thinking about it is okay, I failed at running a 3-hour marathon. On the other hand, I had a great run. I had a great day. It was awesome. I trained hard, and it was and so that wasn't a failure. That was a because 3 hours is an arbitrary time anyway. And as my wife likes to tell me, anytime you can run that long and you don't poop your pants, it's actually a success. So it's all about how you define success.
No, I love that. That might be my favorite definition of success I've ever heard. John Wooden, I come from kind of the basketball. I grew up with playing a lot of basketball. John Wooden, who was a legendary coach, also always talked about his definition as being, at the end of the day, it's about the effort you put in. If you've done your absolute best, and you're the only one who can tell that, I mean, no one else can tell you that you're a failure. That's success.
Right.
Which is I try to live by.
And then when you do succeed at things, you're often sort of disappointed because this okay, well, what's the next thing to do? You're left kind of aimless. And anyway.
We're so focused on success, and we should be focused on happiness.
Yeah.
So what's for folks who might not know you outside of work? Tell us something about yourself outside of BigQuery, outside of work.
I'm a big reader. I've always kind of been happiest with a book. I married a bookseller. And we were kind of fortunate enough to help start a bookstore in Spokane. We helped some of our friends and start one. I think just the world of books is a really important one to me. And I don't really call myself an author, even though I wrote a couple books on BigQuery, or contributed to books on BigQuery. But yeah, I think reading and being curious about the world is an important thing.
And any favorite recent books you've read, or any offhand?
Actually, there's a really interesting it's a Chinese kung fu book, and it's sort of I think it's sort of the Chinese equivalent of Harry Potter. I think it's sold like 100 million copies in China, and it's all about like this. Anyway, I think it's just not that many. I think it was just translated recently, and it doesn't. I think we often can be kind of somewhat blinded by only looking at literature and that's written in English. But anyway, that was a fun read.
Oh, that sounds great. I'm going to stick to my 2008 BI book.
Sounds good. And BigQuery, the Definitive Guide, is also a very, very good read that I highly recommend.
Awesome. And I'll include a link in that. If I'd like to learn more about you and your team's work, where should I get started to wrap this up?
I mean, so like not to be like the professor that assigns their own book, but I do think a lot of what I think is important to know about BigQuery is in that book. You can, but also I think there's some what is it? Colibra, not Colibra. What's the training site? Anyway, there's a bunch of BigQuery trainings online, and to sort of understand how BigQuery works, and some YouTube videos about architecture and stuff, if that's more your speed.
Well, great. Well, Jordan, I appreciate the time again. I'm excited to share this one. Thanks again for joining.
Thank you. Thanks.